we start the final chapter. Yay! So this is all about substitution. And this first part is just an introduction, but let's look at our schedule. Second to last week, notice there is a quiz that opens up on Thursday, and your final exam opens up a week from Tuesday. That would be the 21st, and is available till Friday of that week at 11:59 p.m. And I sent an announcement out about all of this. So we're still working on definite and indefinite integrals. We're adding one more tool to our toolbox, and that is the substitution rule. You may hear people call it fondly U-sub. It's kind of a reverse chain rule. So if you had a function, a composition of a function, and remember that with those we would use the chain rule to find the derivative. Well, what if you only saw the result of using that chain rule? Could you back it up to what that original function was? And the answer is yes. In some cases, if our result is in a certain form, we can backtrack and figure it out. So let's look at what this U-sub thing is all about. The first thing is we look at our integral and we ask, do we have the product of a function composition and the derivative of the inner function? So we're looking for functions in that form, and if we can find them, and it's not always obvious, but if we find something in that form, then we can apply this rule. So let's look at a specific example, and we want to ask, is this the product of a function composition and the derivative of the inner function? So first is, do we have a function composition? And the answer is yeah. X squared minus 3 quantity raised to the third power. That is the composition of two functions. And then the second question would be, are we multiplying that by what just so happens to be the derivative of the inner function? So our inner function is x squared minus 3. The derivative of that is 2x. So we do have the derivative of the inner function being multiplied by the function composition. So it's in the right form. So let's kind of deconstruct it and put it in the notation. So our f of x is x cubed. So the function f is taking something and raising it to the third power. And the thing that it's raising to the third power in this case is what we're calling g of x, which is x squared minus 3. And then the derivative of that inner function, x squared minus 3, we already said, yep, that is 2x, and that's what we've got there. Now, to translate it into this simpler form where we substitute a u, and then we could possibly, very possibly, get the antiderivative. So let's see how that looks. Now, according to our substitution rule, u is going to equal whatever our inner function is. So in this case, u is x squared minus 3. So du means derivative of u. So the derivative of u is 2x dx. All right, so let's put that together. On the left there, you see that we have f of x is equal to x cubed, g of x is equal to x squared minus 3, g prime of x is equal to 2x dx. That's all the stuff that we did in the other slide. So now doing our u substitution, u is equal to x squared minus 3, and du dx is 2x dx. Now we're going to add the final piece. How do we get this to look like it's just a function in u? Well, f of u is equal to u cubed. Remember, f raises its input to the third power. So what we've boiled this down to through substitution is the indefinite integral of u cubed du. And now that we've done that, now here's something that we know how to deal with. we know how to take the antiderivative of u cubed, pretending just for a moment that u is a simple variable. So f of u, as we decided, is u cubed. So what is the antiderivative of u cubed? Again, just pretending that u is a simple variable. Well, we're going to add 1 to the power, divide by that new power. So we get 1/4 u to the 4th plus our arbitrary constant because it's an indefinite integral and we don't know which antiderivative we want. So now that's great. We have the antiderivative in terms of u, but our original function is in terms of x, so we need to do some back substituting. If we trace back, we see that u is actually equal to x squared minus 3. So we substitute that in for u, and we have solved the problem. All right, in the next video, we'll do several examples.